Hello, welcome this afternoon to our Aiven webinar for real-time insights with Aiven for Apache Flink. We're very excited to have you here today to spend the next like 15, 20 minutes to get a quick little update there. I'm going to hand it over right away to Paul, one of our fabulous solution architects. Paul, you can take it from here.
Awesome. Well, thank you so much for that introduction, Anya. Hello, everyone. Thank you so much for joining today. My name is Paul Grainger. I'm a Senior Solutions Architect here at Aiven. So as Anya mentioned, today's webinar, we're going to talk about how we can use Aiven for Flink to realize actionable business insights in real time. So just to begin, just a little bit about myself. So I've been delivering streaming analytical solutions in various roles for the past 10 years. So I've witnessed this evolution from batch to stream processing, and that's what this is. It's an evolution. It's a fundamental shift in how we generate insights from our data. It's something I'm super passionate about, and I'm really excited to talk to you about Flink today. But before we get there, just wanted to take a brief step back and discuss what we mean by streaming analytics. This concept of real-time, or as we commonly call streaming analytics, it has been around for quite a long time. So some well-known examples in this space are financial institutions who execute these complex algorithms in real time based on an ever-changing stream of data, such as stock prices, news updates, social media sentiment, etc. These systems need to be able to aggregate and potentially react as each new event comes in, for which there can be tens to hundreds of thousands of these a second. And these data volumes are only getting larger over time. So as you can imagine, building a system to meet this load requirement is not easy. And speaking from experience, like maintaining it is extremely difficult and even daunting at times. So with that in mind, I want to talk today about some of the challenges I myself have encountered in this realm. I'd then like to introduce Apache Flink and the Aiven platform and how they can help solve these challenges. Finally, we'll look at some use cases which you can use to leverage for these real-time insights, including a real-life example we have from one of our customers in the gaming industry. There'll also be time at the end for a Q&A, so if you have any questions, please pop them in the chat. Okay, so let's look at some of these challenges that used to keep me up at night. So first, performance and scalability. So how can you reliably scale your system as it comes under increased load? More importantly, how do you scale during peak flow events? So if you're at a financial application, you have market open and close. If you're an e-commerce firm, you have days such as Black Friday, Cyber Monday, where you get like an extreme number of orders that your system doesn't deal with on a regular basis. Resiliency and recovery. Unlike batch processing, in which if the batch fails, you just restart it, if a component in your streaming stack fails, how do you recover state? Also, how do you prevent reprocessing the same data, which could potentially cause duplicate flow to your downstream systems? And some of these systems, they can be rather bespoke, and the underpinning technology can be proprietary. Now, there's nothing wrong with that. I've worked with proprietary technologies, and some of them are quite awesome, and they're really good in that space. But the challenge you run into is the talent pool to select from is rather niche. So when it comes to adding new features or maintaining the application, you're quite limited in who you can hire to do this job. And speaking of maintenance, how do you keep your system secure with regular security patches, OS updates, when this application is required to process data 24/7? For example, consider the Log4j vulnerability, which was exposed in December 2021. Those patches need to be applied as soon as possible. But how can you do it without impacting your business's critical workflows? So to try and address some of these, let me introduce Apache Flink and afterwards the Aiven platform. So first of all, what is Flink? You may have seen this squirrel before. So the quote here is taken directly from the Apache Flink official website. But in short, Flink is a distributed data processing platform that can process events at high speed with low latency. And this high speed and low latency is critical to a lot of streaming applications. It can also do the traditional batch style job, but where it really shines and what we're talking about today is how it can perform these streaming analytics. So with just that brief introduction, I just want to go back to our previous challenges and see where Flink fits in and how it helps resolve some of these pains. So first, performance and scalability. Well, by design, Flink is a distributed system, and it will use all the resources available to it in the cluster. In theory, your Flink cluster could have unlimited resources. It just depends how much hardware you can afford to throw at it. Local state can also be stored in a hash map in memory, which enables lightning fast lookups when processing these latest updates. For resiliency and recovery, well, Flink guarantees exactly one state consistency in case of failures by periodically and asynchronously checkpointing the local state to durable storage. Now, this is something you could build. However, it does take considerable time and engineering effort to build a reliable system like this. With Flink, you get this out of the box. As for bespoke systems, well, Apache Flink, as the name implies, is on the Apache license. It's fully open source. It also integrates easily with well-known technologies such as Apache Kafka, Postgres, and as we'll see shortly on the Aiven platform, all you need is knowledge of SQL to quickly build these powerful streaming applications. So I've covered 3 of my 4 pain points so far. What about maintenance? Well, this is where running Flink on a platform such as Aiven has a huge value. So what is Aiven, in case you're not familiar? Well, Aiven was founded in Finland in 2016 by 4 developers who are passionate about open source technology. As such, we provide the leading open source database and data streaming managed services on our platform. We provide the most popular and proven technologies such as Kafka, Postgres, and of course, Flink as fully managed services across all the major cloud platforms, which can be seen at the bottom of the slide here. What's really relevant to this current discussion is our industry-leading uptime SLA of 4 nines, that is 99.99%. This is due to our automated self-healing architecture and our ability to do idempotent upgrades on our services. This gives us the ability to offer our customers 0 downtime on operations such as operating system patches, service minor and major version upgrades, scaling your services both up and down, and even migrating clouds. By the way, for the aforementioned Log4j incident, within a little over 24 hours after this being announced, we had patched and rolled out a fix to our customers with no reported impact to their services. You can see the full details from our CISO on our blog about this. So hopefully you believe me when I say any maintenance on your Aiven service is a breeze, and this can just lead you to concentrate on building your next great application. So let's look at how we can actually integrate with Flink. So on the Aiven platform, we have simple one-click integrations with our managed Postgres and Kafka services. The real power here is that once we have data from these 2 disparate systems in Flink, all we need is simple SQL statements to construct our streaming pipelines. And we're going to see an actual example of this a little later on from our customer use case. From here, we offer outputs to both Kafka and Postgres, as well as OpenSearch. If you're not familiar with OpenSearch, it is the fully open source fork of Elasticsearch. In January 2021, Elasticsearch changed the terms of license, and OpenSearch was the open source community's response to that. With OpenSearch, you get the same great search and analytical features as Elasticsearch, and you can also build great visualization with the dashboards. With Aiven for Flink, you can empower your data scientists, business users, etc., to build what used to be extremely complex real-time analytical pipelines, typically requiring many hours, if not weeks, of engineering effort, simply and in minutes. I'm clearly biased by the big logo on my chest, but from my experience in this industry, that is amazing. The fact that we can just free up our engineering teams to focus on business critical applications rather than just trying to maintain this streaming stack. So what can you actually do with streaming analytics? Well, there's so many options here. We're going to touch on 3 quick points here. As I said, we're just scratching the surface, and then we'll look at how some of this fits into a customer use case. So one very common use case is alerting. And the concept here is quite simple. So say I have data coming in on a Kafka topic, and it contains stock prices. I want to alert or take some action when the price drifts 5% from the previous day's close. Previously, this logic would have been built into some sort of microservice in which the previous day's closing prices would be stored in a static lookup table in Postgres. And as I mentioned already with Flink, all I need to do with this is some simple SQL. This is essentially going to be a join and a where clause. So really simple stuff. The next really powerful feature of Flink is windowing. So this allows you to aggregate over windows of time on the incoming stream of data. So the example on the screen here is identifying taxi hotspots over the last 15 minutes in Manhattan. And this is visualized using the OpenSearch dashboards. So while this concept may seem straightforward, implementing this can be quite difficult. Ensuring that you're maintaining this state across the cluster can be quite a headache. But Flink deals with this so you don't have to. The final example here, and this is becoming increasingly more important, is data filtering. So if your organization deals with data such as PII, HIPAA, GDPR, just to name a few, with Flink, you can easily remove and or mask sensitive fields in your raw inbound stream. You would want to do this so this prevents this super sensitive data from accidentally landing in a downstream system that does not have privileged or worse legal access to this data. So that's just, again, scratching the surface of what you could do with Flink. There's so many more use cases. Just hopefully it gives you a bit of a taste of what you can do. So now let's look at an actual use case provided to us from one of our customers in the gaming industry. So shown here is the high-level architectural view of the data pipeline. So the actual use case here is that we have users laying bets on various games. So each game is given a particular weight. As a customer lays bets, we calculate the total amount weighted by the game value. This results in a score per user, which we can then use internally for targeting that user for promotions and special offers. The weights themselves are static and stored in the Postgres table you see in the upper left-hand corner that's bets to credits table. One really cool feature of Flink is if we decided to update the weights in our bets to credits table intraday, Flink will recognize that and pull in the latest values into our pipeline without any further interaction from us. So the general flow of this particular use case is we have in this example here a microservice. This is just the test case generating bets. So this raw inbound stream comes into the first Flink job. This Flink job enriches that data stream with our bets to credits information, creating a new data set. This data set is now placed onto a new Kafka topic, which could be sent downstream into other systems. Now, this could be used then to trigger alerts or maybe suspend the user account if worrying or fraudulent activity is detected. But what else we'll do with this data is we'll actually push this into an additional Flink job, this aggregate bets Flink job. Here, we are going to use some of the windowing functionality we just looked at to aggregate the data, and then we're going to store that data in OpenSearch, and we're actually going to use Grafana to visualize it. So here, just to show you how this would look in the Aiven console. So if you're not familiar, this is our Aiven console. This is our single pane of glass view into all your actively running Aiven services. So here, for instance, we have 5 active services: Postgres, Grafana, OpenSearch, Kafka, and Flink. The UI allows us to interact directly with our services. We can view metrics and logs. We can create new services. We can change configuration, etc. This is just one way of interacting with your services through Aiven. We also have other options such as command line tools, Terraform providers, and Kubernetes operators as well. But here's what I really wanted to get to, which is the simplicity of building a data pipeline in a streaming data pipeline in Flink. This is it. So here I have data coming in from both Kafka and Postgres. And all I'm doing is very simple SQL. I am simply doing a join of these 2 data sets and then inserting into this best topic. You can just consider best topic as just a table in your database. We just do a simple select with a join, insert our data, and now we have this enriched data structure we can send to the rest of our business. And that's how simple this is. The next stage of the pipeline. So the SQL here is a little bit more complex, but if you're confident with your SQL, you can see here, it's a simple aggregation. We're doing a count to sums, and we're grouping by a user and a window. And again, we're interacting with a completely different technology here in OpenSearch, but yet again, just a simple insert into that index to push the data into it. One really nice feature of Flink, and we don't have time to really dive into it in today's webinar, but is the Flink dashboard. So this is a really great tool in debugging your jobs. So here you can come in, you can view logs of the jobs. And also, if your job is misbehaving for any reason, maybe the SQL query was constructed incorrectly, you can come in here and you can actually view the data that was used to generate that data. And then just the final slide, just for this very simple use case, is just how we could visualize this data that we've produced from our aggregation. So again, this data has now been pushed from our Flink job into OpenSearch. It's been aggregated into 30-second buckets. We are visualizing the total number of bets per user per minute, the total dollar waged per user per minute, and the total credits, the total score as well that we've constructed using our credits from our lookup table. So these dashboards will be updating every 30 seconds as new data comes in. But again, this is just a very simple use case, but hopefully it highlights the power of this technology. And just a little bit of insight, when I was a lot younger, I actually worked briefly in this industry, and I know for a fact that getting this data is invaluable to parts of this business, such as betting and running traders. They need to be immediately able to suspend accounts if they spot any fraudulent or suspicious looking activity. Otherwise, they're going to be liable for severe financial consequences and even worse, reputational loss, because no one will want to do. If you're laying bets and you know this company is accepting this fraudulent activity, you won't want to be a customer of them. And that concludes my presentation. Well, thank you so much for joining today. I will now open shortly for Q&A. So if you have any other questions, please enter them in the chat box. If there's anything else after the event, my email and LinkedIn are on the screen. Please feel free to reach out to me. Also, if you're interested in checking out Flink, I highly suggest signing up on our website. Use the code Apache Flink NA822, and you'll get $300 in trial credit to start building your next great application. Well, awesome. Thank you so much.
Thanks, Paul. Actually, yeah, I have a couple questions here, so I'll throw those right your way. Somebody said, I see that Aiven for Flink is in beta. When will this be GA? And are you planning on supporting more integrations?
Yeah, great question. Yeah, so that's correct. We're currently in public beta. We're looking at a Q4 GA release, which we're super excited for. And yeah, as far as integration, so what you saw today is what we'll definitely support. We are looking to support a Slack sync integration towards the GA as well. And all I can say is watch this space, that we are not limiting it to these technologies. We are looking for feedback from the community. If there's anything you would like to see for a Flink integration, please let us know. We will we would love to work with you on this.
All right, great. The next question would be, you only mentioned SQL. I've used Flink in the past and written my own custom code. Do you not support that?
Another great question. So as part of our public beta, that's correct, we are only using SQL. So if you're familiar with Flink, that is the table API, I believe. However, we are investigating, and it is on the roadmap, to support custom jars. So again, I'll say watch this space. It is something we are considering and hoping to roll out sometime next year, hopefully.
All right, awesome, thank you. Yeah. Then there's one more. I'd like to store my Flink job definitions in source control. I can't do that with your UI.
Yeah, great question. So I mentioned earlier, so while what I just showed today is just how it would be constructed in the UI. We do have Terraform and command line interfaces with the Aiven platform. So using Terraform, you can bring up your entire Aiven infrastructure, including the job definition. So you could write your SQL store in Terraform and persist that through your usual CI/CD pipelines.
All right. Awesome. And one last one I see here, how do you monitor the health of the service?
Another great question, and this kind of ties into the overall value of the Aiven platform because it's something we don't just offer for Flink, but all our services. So we do have native integrations for metrics with our provided M3DB. So M3DB is a time series database, and we also provide for log integrations directly with OpenSearch. Apologies. And on top of that, we also have pre-built Grafana dashboards for all our services, so you can just immediately spin these up and view the health of your cluster. We also offer third-party integrations as well. So if you like using technologies such as Datadog, we have integrations with our services so you could just use those as well.
Awesome. Yeah, I don't see any other questions. Of course, Paul's information is right there. Feel free to reach out. We hope you give Aiven a try and use our code for some free credits. Also, we have our nifty data sheet online if you would like to download that, but we happily send it to you as well as a follow-up. So with that, thank you so much, everybody, for attending today. And we hope to see you at our next Aiven event, webinar, or just on the road. So see you soon and have a great day. Thank you so much.
All right. Thank you, everybody.